All right, guys. We're going to go over the algebra prep questions part 2. So the first problem, this one says, actually the only problem, there's just multiple parts. This one says a skydiver is 600 meters above the ground when he opens his parachute. After opening the parachute, he descends at a constant speed of 17 meters per second. So part A is asking us what type of function would best model this situation. Explain your answer. Okay, so the ones that we've talked about mainly are going to be either linear, quadratic, or exponential. And there's something in this paragraph that is going to tell us which one this is. And it's this word right here, at a constant speed. So if you're going at a constant speed, you're not accelerating, you're not decelerating, you're just constantly going at, let's say, like +2, +2, +2, +2, +2. And what that's gonna give you as time goes on, you're gonna notice that you just get a straight line. And we know that straight lines, straight line, it's kind of got the word in it, line, linear. So we know that this function type is going to be a linear. Let me circle, I'll just circle that. So it's going to be a linear. And they're asking for a reason why. Well, the reason why the problem stated we are decreasing at a constant rate of 17 meters per second. So as long as you mention this constant rate right here, that's the reason why. You're gonna get full points for this. All right, the second part B, says write the equation that models this situation. Okay, so let's pick out all the numbers in the top part. We've got that we start at 760 meters above ground, and we have that we are descending at a rate of 17 meters per second. So if you wanted to write an equation for this, you could say y equals, what's our y-intercept? Where do we start at? Well, we're starting at 760. That's at the very top, 760, and we're decreasing, so we're gonna put minus. We're decreasing at a rate of 17 meters per second. And then this is where you're gonna put your variable. It's meters per second, so we're going to put, I'm going to use x. So this is your function. So this is what you can use to figure out any point in the graph where this skydiver is at. For the graph itself, your graph may look different than mine. So I'll say your graph might look different than mine. The reason being is because they didn't give us any numbers on the y and x axis, so we're the ones deciding that. So that's kind of an opinion. So in my personal opinion, part C of this question is not a very good question, but nonetheless we're going over it. So what I did is I said that this was 100, 200, 300, 400, 500, 600, 700, and I went up to 800. I don't have to go any higher because the max is 760. So this is our height in meters. And then this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 9, and 10. These are our seconds. This is as time is going by. So at time 0, that's our y-intercept, that's our y-axis. So we're at 760 for time 0. So I'm gonna put a dot here. And then we're gonna go down and to the left by 17. Now, between 800 and 700, there's a lot of numbers in there. So as long as you're rough somewhere in the ballpark, what I did with mine is I got my calculator out and I went, okay, 760 minus 17, minus 17, minus 17, minus 17 to see how far down I should go with each one. So this is what I got. And like I said, I'm not too fond of this question anyway. So as long as you got something, well, yours is gonna look different. So this is just one way that you could do this problem. How about that? All right, and now let's connect it. Oh gosh. Something like that. So it's gonna go all the way down somewhere over here. So that's part C. Let's take a look at part D. It says, write an equation that would represent the number of seconds it took the skydiver to reach a height of 400 meters. Use the equation to solve for that time. So we're gonna take our equation that we had on the front. So that was y equals 760 minus 17x. And it wants to know when we reach a height of 400. So what this equation is giving us, this is giving us the height. So we're gonna plug in for y, that 400, and figure out how many seconds it takes to get to 400. So let's plug in 400 here. And now we can just solve for x. So I will subtract 760 on both sides. These cancel. This gives us negative 360. This is going to be equal to negative 17x. And I will just divide by negative 17 on both sides. And what I get is x is around 21 point, I'm rounding, 2 seconds. So in 21.2 seconds, that's how long it takes for him to reach a height of 400. If you want to plug that in, you can, and you'll see that when you plug in 21.2 into x, you get around 360, and then when you take 760 minus 360, you get 400. So this is our answer. All right, and part E, the last one, what is an appropriate domain for the situation? So just remember that domain is all of your x values. So domain is all of your x values. So right off the bat, we can eliminate C and D because they're not talking about x values. So let's scratch these out. Now let's look at A and B. So we've got 44.7 and we've got 760. We're starting at 0 seconds. So if I was you, what I would do is I would plug in 44.7 and I would plug in 760 into the equation and see what you get. When you do that, you're gonna find out that if you plug in 760 into this equation, that you are going to get, let's find out. Let me get a calculator real quick. So, if I plug in 760 minus 17 times 760, it looks like we're gonna get a negative number. So let's just see what we get. So 17 times 760, 760 minus, yeah. So we're gonna get a negative number here, and we don't want so we get negative 260. Does it make sense for our skydiver to be at a height of negative 260? Not really, unless you're talking about going below sea level, and no, so not really. Let's plug in, let's try 44.7. So 760 minus 17 times 44.7. Let's see what we get. In fact, so 17 times 44.7 gives us very close to 760, so 59.9, and if we subtract that, we get 0.1. So that is really close to ground level. So this is pretty much the maximum amount of seconds we can have. So this is saying we're gonna go from 0 to 44.7 seconds, and that's all we care about. That's everywhere from 760 to the ground. So this is the one we care about. We just care about A. The other one we don't care about because we go into negative height. So A. If you got any questions about that, please message me and I'll be happy to explain it a little bit more. All right, bye.